All right, so what we're gonna do is um, we're gonna talk about area and volume, and also I think we talk about your fourth quarter grade is basically how I think of you. Most of you guys will still have no problem. Like if you're doing your work, you're showing up to class, you're showing up on mock exams, and then try your best at everyday code. And the rest, it's pretty much an easy A. But only if I don't see you put in the effort. So it really depends. You want based on the actual test score, or you want to base on actually how I view of you. It's much easier to see. Yes. What?
The third quarter grades, like in the ratings you had to do?
Yeah. Did you have it?
Yeah, I did that one, and then like the other FRQ rating.
The other FRQ is fine. You did fine. You got 85 is fine. Which one?
The
Oh yeah, that one I still haven't changed the grade them yet.
yeah, that one, like the very first.
Yeah.
Thank you.
So the area and volume test, it will be not on this before the break. It will be after the break. But in the break, you do have a multiple choice questions you have to do for me, and that's gonna be a lot of practice for the MCQ. It's not just going to, you actually have to go in to try your best on that. Like I said, it's gonna be, the grade I'm gonna see is based on what kind of work you turn it. Like the work, if you trying, I can see you trying. By looking at do things, I see you, okay, you're putting effort on this question, you're putting effort on this question. So 90. I usually assign 4, so it'd be 180. Multiple choice. Multiple choice.
So wait, is it 90 or 100?
90. Hey, you guys are so late. Why you guys are so late? You guys did good?
Yeah, she's semi-final. Yeah, she's semi-final. Whoa! Yeah, final, they'll be off their final. And then we got
All right, so here's the thing. All right, so we have two functions, f of x and g of x. How do I find the area of this? Okay, so the idea is, how many of you guys know how to find the area of this? All right, so besides Larissa, does anybody else know how to find area? Good, good, good. Emma, what do you think? You don't know? Lee, what do you think? Caden? The hand is on the graph. F of x and g of x, A and B. Fabian, what do you think?
Oliver told me.
Oh,
Oliver, what do you think?
how about Olivia? What do you think? You don't know?
Yeah, Olivia showed.
Apple, what do you think? Integral from where to where? And which function? F of x and g of x? And what do you do with f of x and g of x?
Oh shit. I guess. Well, hold on.
Yeah, good job. So you find an area from here to here, and you first find the area of f of x, right? Which is that's the big area. Then you find the area from here to here, and you subtract from the big area and small area, right? Does this make sense? So it's going to be integration from a to b of f of x minus g of x dx. So in this particular case. However, we don't always define the top as f of x, or we don't always have type bottom x as g of x. So we're going to say is between a to b of the top minus the bottom dx. Top function minus the bottom function. Yes?
Will we always knew which function is top and which one is bottom?
That's a great question. Do we know which function is on the top, which function on the bottom? What if I don't know? I'll give you two random functions. And how do you find out which function on the top? What'd you say, Hannah? Degree doesn't tell me which one's on the top and which on the bottom. But you can, yes. Yeah. So what Lyndon suggests is actually a good idea. He says, hey, if I between A and B, just because between A and B is 5, I'll plug in 5 and see which one's higher and which one's on the top and which one's on the bottom. That's the most intuitive way to find it. What's on the top, what's on the bottom. Is that okay? Now, this area here, we're basically adding up here, 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 and just accumulate them and all the way to from A to B. Now today, what if I give you a function? I says, hey, y equal to x squared plus 2. And y is equal to negative x. And x equal to 0. And x equal to 1. I want to find the area between all those bounded. Wait, Jacob coming? So this is negative x. Do you guys graph it? So first one is x squared plus 2. How many of you guys don't know how to graph x squared plus 2? Okay. All right. So let's start with Caden. Do you know what x squared graph look like? What is up? Like, you are somewhat right, but what is up? What do you mean by up? You don't know? Oh, okay, that's good. Okay, that's fair. Okay. So it's a parabola because of x squared and the x squared plus 1 plus 2, that means the parabola go up by 2. Yeah, so it's going to be like something like this. Okay. And the negative x, how many of you guys don't know how to graph negative x? Lee, do you know how to graph negative x? Don't whisper to him. Is what?
Negative slope.
Good. Negative slope. Is that what Leon told you? He didn't say a word? It's gonna be a -1 slope and go through origin because of the x. X equal to 0? What the graph x equal to 0? Samuel? What's the x equal to 0 graph look like? Larissa?
X equal to 0.
What's that graph look like, x equal to 0?
Isn't it just literally what is there?
Which is what?
The y equals x squared plus 2 has a point.
No, x equal to 0.
Just a straight line. Horizontal line.
It's a vertical line. Those of you guys don't know what x equal to 0 graph is, start a vertical line. And there's another vertical line here at 1. So basically, we are looking for the area of this region. How many of you guys have this? Okay.
We had to draw it.
Yeah, that's why at first we want you to draw it because
It's where they all.
Yeah, is it 17 over 6?
We got it right. We got it with that drawing.
huh?
We got it with that drawing a graph. Do you have to draw the graph?
Yeah, but how do you know which function's on the top?
Because you like you have x.
Which x value? Okay, that's fine. I mean, but what? You can just tell. Yeah, in this case, you can just tell because if you know how to graph it, though. But that's okay. So it'll be integration from 0 to 1. And the top function will be what? X squared plus 2 minus negative x dx, right? So that's 0 to 1, x squared plus 2 plus x dx. This is going to be x cubed over 3 plus 2x plus x squared over 2 between 1 and 0. If I plug in 1, and that's going to be 17 over 6. Any questions? 17 over 6. All right, so I'm going to ask you the second one. F of x equal to 2 minus x squared. And g of x is equal to x. This one I'm going to guide you first. I want you to try to graph it first, though. What? Exactly. So this one is actually is known as the area. So area between two intersecting graph indefinite integral. No, it's definite integral. Okay, then where's your boy Jacob? Yeah, that's like half hour ago. Is it? Okay, so okay, the keyword's intersecting, right? So can we find the intersection is? How do we find intersections?
Good job again.
Okay, so can you tell me when is those two functions equal to each other? Not 1, 1.
3-1.
1-1.
0.
X squared plus x minus 2 equal to 0. Can I factor it? X plus 2, x minus 1. Can you solve it? X minus 2, x equal to 1. So negative 2 and 1. So which function's on the top? Why? How do I know it's a bigger one? You plug in 0 for both. If you plug in 0 for both, the first one's going to be 2, the second one is going to be 0. So we know that the top function is on the bottom. But in case you don't know how to graph, is this one is x squared is like this and go up 2, but it's facing down. So it's going to be like something like this. So this is the graph. And the x is going to be something like this. So we are looking graphing here. Is that okay? So yeah, it would be integration between what? -2 and 1. 2 minus x squared minus x dx. Now, I'm going to mention one more thing, though. Please put a parenthesis all the top and bottom, because sometimes it's needed to distribute, and if you don't have a parenthesis, especially when you type in the calculator, because if you want to get the right answer, make sure you type in a parenthesis. Because you let calculator do all the work, but you still have to put a parenthesis, and then you have to put a final parenthesis at the end. So you probably at the end you need another parenthesis here to actually have them do it correctly. Otherwise, it will come out as error. So now it's going to be integration from -2 to 1. It's going to be 2x minus x cubed over 3 minus x squared over 2 between -2 to 1. So what I would do is I plug in the boundary. So it'll be 2 times 1 minus 1 to the 3 minus 1 to the half. All the way minus, if I plug in -2, it's going to be -4. If I plug in -2 to the cube, it's going to be -8, but it's positive 8 over 3. And minus 2. One thing here is I don't subtract. I show you a trick. Sometimes the power of common denominator is much easier to take care of those. If you realize this is a 1 over 3 minus 8 over 3, what is that going to be? Minus what? 9 over 3, which is -3, which is so much easier than try to add and combine the fraction of the first one and trying to combine the fraction of the second one. I can pay attention to that. And if I pay attention to this one here, it's going to be 2 minus -4, so it's 6. Is that okay? The last one here, between -half and +2, this one is going to be +3 over 2. So that's equal to 3 plus 3 over 2, which is 9 over 2. So I can use the same denominator for you to subtract them. Your life is going to be faster. It's going to solve problem is going to be faster. Is that okay? Okay, I'll ask you to do one. I'll ask you to do this one. X squared plus 2x, g of x equal to x plus 2. You guys get it? What you guys get?你在忙吗？没有，那个你可不可以帮我煮个饭？那我有那个 ham。如果要出去，我帮我带那个没有很多。你会出去吗？还是不会出去？Hello。Hello。OK。Okay, you guys got it? No? Take kind of long. Well, let's just say 80/6. I don't think so. I'll leave over to get. Okay, so I don't know what a graph look like, and I'm just gonna find the intersections. So be x squared plus 2x minus x equal to minus 2 is equal to 0. X squared minus x minus 2 equal to 0. X minus 2 and x plus 1 equal to 0. And we don't know which one's on the top. Which one's on the top? X plus 2, good. So that's going to be from -1 to 2. And this is a x plus 2, right? Be careful. And this is why I say parentheses is very important. Because if you got a parenthesis, you forgot the distributions. So you must have a parentheses. How do I know which function's on the top? How do I know which function's on the top again? Plug in 0 because that's between -1. Good. So that's going to be -1 to 2. Negative x squared minus x plus 2 dx. Does that make sense? Because x minus 2x is minus x. Do you see that minus the sign of distribution? If you don't have a parentheses, it matter. Yes?
How do we get -1?
I set equation equal to each other. Oh, there's a plus x. Oh yeah, you're right. There's a plus x. So this one is going to be plus 2 minus 1. So x equal to -2. X equal to 1, right? So sorry about it. Thank you. It's going to be -2 to 1. And then I will worry about negative x cubed over 3 minus what? Negative x squared. Sorry, this is x squared over 2 and then plus 2x between 1 and -2. I plug in -1. So you see it here, right? Do you see the common denominator? That's end up to be -3. Does that make sense? This one end up to be positive 3/2. And then plus 6. And it's still gonna get 9/2.
Yeah, I got that. Yeah. I got that.
Yeah.
No, that's
All right, so is this okay? Okay, the next one is curve intersect more than 1 point. So this one I want you to use decimals because this one's kind of hard to graph. Three x squared minus x squared minus 10x. And the g of x is equal to negative x squared plus 2x. Okay, I won't use decimals. Plus 2x. Three x cubed minus x squared minus 10x. And the g of x is equal to negative x squared plus 2x. And I want you to use decimals on this one. I want you to use decimals on this one. I don't want you to evaluate them. I want you to use decimals. So you can get your calculator, figure out.
You have no idea.
I think it's Nicholas Lester.
Oh, I could believe that.
He's a nice guy.
No, it is so cute.
Was it 12?
No.
No. Wait, you said more than 1 point.
Did you use decimals to graph it?
Mm,
Huh?
That means to do integration plus science. Maybe you do that. You do that integration. It's just for farthest. Kind of like Q and Q, that's when it's station. Then there to make this way. You know, when you do integration, no. Because you like this here, right? And then say it. Oh yeah, can you minus 12? Let's see, just use that.
What?
24.
Why is 24?
You have to add first one because they intersect more than
And what do you have to do with a function, though?
I added this one.
Do they have different top and bottom?
So I did it separately and then I added this.
Okay, have one person got an answer? Hurry up. Get on the phone.
Me and Olivia.
That was your one.
Yeah.
Yes.
Which is
So they crack something. Right.
what I would do is set
Really?
yeah.
Next month is
And this one is here.
Or what did you say? That's
And then our restaurant is also online from
Yes. Oh,
one.
You have to add the two intervals together. Zero?
Do you think area could be 0?
No,
All the time we're doing all this work. It is.
Yeah, what's your answer? Yeah, it's 24. It can't be. It is?
because I'm taking 12 and I'm taking my
Can I just ask you about it because
0,
So,
give back to mine.
you have to decide which one's on the top, which one's on the bottom.
or 0 to 2, which one is on top? Is it the red? Yeah. So blue is G of X. Here is G of X minus X.
Yes. If the second number is negative and you're adding them together.
no, it's not. Look, it's because you did it wrong.
I just grabbed it. First here,
Oh,
Which one?
negative 2, top here.
I think it just goes back to from 0 to 3. What are we to do?
Okay, so if you realize that
Do we have a Euro quiz?
okay, so we do need to realize that there's two different top and bottom, and they are two different region that you have to worry about. So 3x to the cube, right? And then minus x squared, and then minus 10x, and g of x equal to negative x squared plus 2x.
I'm putting you on for base second right?
Okay, so now you get a find intersection between negative 2 to 0. So you gotta do integration negative 2 to 0. Okay? And then that's gonna be f of x. Wait, it's f of x is on the top. In this case, minus g of x. And I need a parenthesis here. And the dx. And then you're gonna have to do integration. It's gonna be 0 to negative 2. Of g of x minus, because g of x on the other side is on the top. 2. And then it's gonna be parenthesis g of x minus f of x. And that's 12. So it's 12 plus 12 is equal to 24. Okay.
So do we have to use watermelon?
No. So the next thing is you will have integration from A to B, top minus bottom, dx. Okay, and also that you're gonna have a second one is C to D, right minus left. dy. Now, why is dy? Because it's the other perspective. Now, do you realize that C and D is different than A and B? Because C and D is an intersection of the y value rather than the y coordinate rather than x coordinates. So today I can have, say, g of y, which is also known as x equal to 3 minus y squared, and x equal to y plus 1. Okay, so this one you cannot use decimals, but I'm going to show you how to graph it. Without using decimals, I can say, hey, let's graph this. Okay. In this case, what is you're gonna have like say, wait, how do I graph 3 minus y squared? X equal to 3 minus y squared. Think about y equal to x squared is a parabola facing up and down, right? So yes, it's turned to the side, but which side does it turn?
Right.
Left. And then it's gonna go up 3, but at that y perspective, it's going right 3. So therefore, this graph will be like something like this. Yes, it failed vertical line test, but it's not a function, but still can be expressed. It can still be expressed to graph it. Now, x equal to y plus 1. So it's probably hard to graph. Think about this. So it's even hard for me. So y equal to x minus 1. I'll just convert to y because that's fairly easy to think about. So that's going to be negative 1. It's going to be negative 1 and 2 here. Okay, so then you say, hey, I can set those two equations equal to each other. So 3 minus y squared equal to y plus 1, and then that's going to be y squared plus y minus 2 equal to 0, y plus 2, and then y minus 1. So y equal to negative 2, y equal to 1. So it's still, this one is going to be negative 2, and this is 1. Now, do you realize I'm calculating this way, and you're going to be like, wait, Mr. Can I do top minus bottom? The problem, you cannot do top minus bottom. Because you do top minus bottom, in this region is okay. Because this region, there's a top part and there's a bottom part. They are two separate functions. But in this region here, they are the same function. So if the same function subtract each other, it's not like you cannot do it. It's kind of weird. It's like, it's 3 minus y squared minus 3 minus y squared. It's actually 2 times 3 minus y squared, which is kind of weird. So it's really hard. So you had to break the two integrals, because this region, the top minus bottom, it doesn't work. And that doesn't work. It's more complex, and you need to do 2 separate integrals. Or you can do it here. I just do it 1, which is much better to do it 1 than 2, and that's going to be integration of negative 2 to 1 of 3 minus y squared minus y plus 1. Is that okay? And this will end up to be 9/2 still. And you're gonna see like there's a lot of answers 9/2. It's not all the answers 9/2. It's just it just and this the graph is really easy to illustrate. It's the same graph but illustrate in a Y perspective. Yes. You can plug in I graph it, but if I would do it, I will plug in 0 for Y and see what happened. So 0 for Y, if I plug in 0 for 3 minus Y squared, that's going to be 3. So that is the most right. Okay. So the idea we want to find is top minus bottom, right minus left, finding intersections. And maybe there's more than one intersections. You have to do 2 different separations. Like, for example, this situation that we did on Desmos, right? So that's area between the curve. Yes. Caden? Oh, vertical line test because if you go into here, it's gonna hit twice, and that's not a function. So if algebraically x equal to 3 minus y squared is not a function. In terms of if you worry about on SAT or whatever, that's not a function. A function is represents every input, every x input, there's only one output. But in this case, every x input has 2 y output, so that's expressed as not a function. Is that okay? Can I move on? Okay, so with that being said, we are gonna worry about volume, which is for me, I think it's not as bad, but for a lot of people, they think this is the hardest part of the test. Fortunately, at most, it's only count for one FRQ, not multiple FRQ, so only one FRQ, but still worth 9 points. And out of 9 points with area, you should be able to get 2 to 3 points. Now, its rest of them is a volume. How do you get those things? Volume is very difficult. I personally think this is an important part of calculus. College Board think it's like, it's okay. You can probably get a 4 without it, but you still need a 5 with it. So for this particular question, we're gonna start finding, like, say, hey, how do I find a volume of, let's give you a general shape. Can you find a volume of a basketball? Yes, that's a sphere, you're right. What's the volume of a sphere? 4/3 pi r cubed. Great, you guys have very good. Now today, if I says, how do I find the volume of silo? Silo, like the things that put grain. Yeah, they collect the grain inside the silo. SILO.
We all never played it.
Gonna be like a cylinder. Oh, like a dome.
It could be a dome or it could be a cone. I don't know. Depends on which kind of silo we're talking about. So those of you guys don't know what is a silo, it should have a shape of a cylinder and a cone, or a cylinder or a semi-sphere on the top. They store the grain in there in like Midwest. So
You wanna die once?
So what I would do is I'm going to talk about, well, those are the shape that we can find is a composite. That's fine. That not all shape can be able to find volume, right? So for example, today, what if we talk about football? is any geometric formula to help you to find the value of football? That's gonna.
Pointing over the block.
Football.
What else would it be?
No, but it's not.
Yo, focus up.
It's a football.
All right, so shh. So what I want to say is how do you find a volume of a football? Or how to find a volume, for example, let's just say, let's say a vase.
Put it in water.
Like, how do I find the volume of this vase? Okay, so then you say, wait. Some people say, yeah, I can put in the water and then pour it out. Yes, that's one way to do it, right? But how do I using algebra or calculus to find the volume of the shapes, right? So you got a lot of different shapes. So you got a vase, you know, all different kind of vase. So how do you, Jacob, I cannot talk over you. Okay, thank you. How do you find the volume of a vase? So what I do is today I'm gonna do some demonstration to show you. The reason why the football is I mentioned is I can come up a algebra formula. It looked like kind of like a curve of a football, not a whole football, but a curve of football. So, and the way I propose is this.
You can't see. You can only see the bases.
The way I propose is y equal to square root of x. Okay? Why do I propose that? Because square root of x looks like something like this. And we stop at 4. So stop at 4 here. So start right here. And end right here, we're gonna cut off at x equal to 4. Now I want you to do is imagine I have this graph and I have another thing called axis rotation. So that means I'm gonna rotate around x-axis. I'm gonna rotate around x-axis. And when I rotate, that means rotate inside the board and outside the board. Okay? It's kind of hard to picture this. Does anybody can visualize that?
Almost like a cone, but it's curved instead of like a straight line.
What'd you say?
Almost like a cone, but it's curved instead of a straight line.
Okay. It has what? Half of egg. Okay.
Yeah.
Or we can solve it half of football.
Yeah.
Okay. Huh? Half an egg. I usually do this demonstration for you guys, but you guys probably see the idea. But I still wanted to, like, one of my favorite professor, his name is Dr. Lee Wen. He teaches physics in MIT. And I really like him because he says at the end of the day, usually kids are not gonna memorize any formulas. Because by the end, nobody ever memorizes formulas. So what I will do is I will show you that a rotation I'm gonna try to do it this time with a wider surface, so just have a screwdriver over it, but okay, that should work. What?
Like it.
What'd you say?
Do you believe that?
You have water.
I don't think.
You got it, bro. You just
What?
I was encouraging you.
So, so it basically, I want to show you the rotation. So do you see this rotation? It's basically, I cannot rotate here because I don't have enough leverage. So I can rotate. So it's gonna have a whole watermelon, right? What? Spin what? Spin a watermelon? Hold on.
Wow.
So what happened is I'm gonna rotate this, and if I rotate like this, right? I'm gonna form like a football. This is the x-axis. I just cannot ding forward, but you get the idea, right? But here's the thing. Imagine that I'm rotating and you seeing in this perspective. Okay, you see it in this perspective, right? But what kind of shape, if I just see like this way, what kind of shape you gonna see? Just from this, from your perspective. Square? You're gonna see a square? A circle. Okay, a circle, which is, that means you're gonna see a circle like this. Okay, so you're gonna see a slice of this. So imagine if I take this watermelon, right? Imagine I take this watermelon and I only care about this radius right here. And this radius is gonna have, so imagine if I cut multiple pieces, let's say it's 5 pieces. I'm gonna add at each slice of a disc. And if I'm going 2 or more here, what happened to the disc? Smaller, right? And what if I can sum it up, which is the idea of integral, is to adding every single slice. Does that make sense? So the slice is going to be 1 disc, 2 discs, 3 discs, and you're going to add an infinite amount of stuff. Now you got a half a watermelon or half a football. And then you can find the value of this shape using a disc method. So what you're gonna see is when you get to here, and I'm gonna rotate, And this is the first rotation of the biggest part of the circle. And this is the area of a circle, pi r squared, right? Now there was infinite amount of slices, so I hear there's a small slice here. That's pi r squared, but my radius is different, right? But radius is from 0 to 2 throughout, because square root of 4 all the way stop at 2, the radius is maximum 2 and minimum at 0. Does that make sense? So because this one is going to be a small slice. Now I'm going to show you another visual for you guys to see. This is another visual that if I pull it out from here, this one is another way to show you a visual is because, yeah, it's pretty crazy, right? So first of all, this is the function, because a lot of time people cannot see this is original graph, right? And if I rotate a little bit to see there is a little bit of dimension to it, and then if I rotate around here, and you see that boulder shape or half a football, then you can say, oh, okay, I can find the value of this. And it's a shape that we cannot graph from geometry. But we use the idea of geometry, which is area equal to pi r squared. If you look at the base, right? If I get a function of the curve of the base, and I plot in on the coordinates, and I rotate around x-axis, I get value of a base. Long as I have a function of the curve, which is you can use regression, just plug in, and you can ask decimals to do that, and then boom, done. Does that make sense? So this is a very powerful tool because this can find any value with some type of symmetry. Some type of symmetry, right? If you have a symmetry, that you should be able to find a value. Now, asymmetry is probably not able to do it, but a symmetry should be able to find out. Now, with that being said, I can find the value of this using this idea, which is the disk method, because this part is a disk. And we're going to add up all the disk, which is the integral. So we start with the disk, it's pi r squared. That's not enough. That's only one disk. But I'm going to add the infinite amount of disks between 0 to 2. And that's going to be integral between a to b. Don't forget the pi, because it's pi times r squared. Now, what is r in here? We're going to just put r of x squared dx. It's not r times x, it's r of x. R of x just means function in terms of radius. Now, if I have function in terms of radius, but we are thinking about what is r here? What is r in terms of this function? Well, the r is square root of x. Does that make sense? Because what happened when x is equal to 4? R is equal to 2, right? So r is equal to 2, right? What happens 1? The r is equal to 1, right? Because I can plug in the function. So this is the disk method. So in this particular question, can I just say, oh yeah, that's just integration from 0 to 4 pi square root x squared dx.
Why is it 4 again?
Because we say stop at 4. We say we're going to stop 1, 2, 3, 4. We're going to stop at 4.
Okay.
Like a 4-inch, like 8-inch long football.
So like in these problems, is it going to tell you?
Well, I will tell you where to stop, yes. We will ask you to draw the picture, and we will ask you rotation. So you say, oh yeah, that's actually fairly easy. Okay, so let me ask you, is it possible for you to find a volume of cone but using calculus? Volume of cone using calculus. And this one is 0 to 4, like this, but it's It's a straight line. Okay? What happens if I do a rotation? What kind of shape am I going to form? A cone, right? Okay, so can you use calculus to find this cone? And I want you to find it. Yeah, go to 4. Same x value, same x4. And the reason why I do demonstration is not you cannot see it, is like I want to form a imagery for you to know, because at the end of the day, you know, a year later when I told you this method, you'd be like, I don't remember that. But at least you're gonna remember me taking a watermelon and drilled it and do a rotation and show you what happened. Stop at 4. Oh, I have no idea.
It's just like, you just look at the graph. The only thing that makes it complicated is the fact that you look at it, no one, because it was just a line.
Yeah. What'd you say? I cannot hear you. What happened? Square root x squared. That's the r. Square root x represents the r, the radius at any given x value. No. This problem is different. This one, I want you to find this value of a cone. Right, this cone is a sideway. Right? So let me ask you, what's a function here? What's an r of x here? 1/2 x. So it's 1/2 x. Do you see that it's 1/2 x? Because the slope is what? A half. So in this case, it's not square root of x, it's 1/2 x, right? So this is y equal to 1/2 x, also known as a radius. Because if I have a 4, then it's 2. If I have 2, it's equal to 1. So can I say pi r squared 0 to 4? What is r? 1/2 x squared, right? Does that make sense? So it'll be pi 0 to 4. Because it's r of x. R of x is 1/2 x because the slope is 1/2.
Okay.
Yes.
Do we not put the 1/3? Like the volume of a cone is 1/3.
No. I will show you why. So 1/3. So this is 1/4, right? X squared, right? So that's gonna be x3 over 12 between 4 to 0 times pi. And that's pi equal to 64 over 12. which is equal to pi over 32 over, wait, hold on a second, 4, so it's 16 over 3 pi. The volume equal to 16 over 3 pi. Guess what? If I use exactly the volume equal to 1/3 pi r squared h, right? But it's 1/3 pi. The radius is 2 square times h is 4. Guess what? You got 4, 4, 16, 16 pi over 3. And you're gonna be like, why would I bother to use calculus? Because not every vase look like a cone, right? If I really want a base formula, is all I gotta do is use regression to find out something like this and stop right here, right? What happened in rotating around x-axis? You're gonna have this weird looking shape, right? And that's gonna be a rotation, and that becomes your base. Okay, do you guys see it? Okay, so that's the volume of disk. Now I'm going to talk about washer method. So this is this method. This method is, I'm going to say that again, the disk method is integration from a to b of r of x squared dx. And don't forget pi, because you forget pi on the test, that's wrong. As a 0 as opposed to the full square. So if you don't forget pi, and don't forget a parenthesis as well. When you have something parenthesis square, don't forget a parenthesis. Is this okay? Now with that being said, we know the disk method. The disk method can be in terms of y perspective as well. So that's going to be pi c to d r squared of y dy. That's a function in terms of y. Now some people say, so what is r of x? R of x is the distance, usually distance from axis of rotation to the function. And sometimes it's the function, sometimes it's not, but it's distance from the axis of rotation to the function. Is this okay? So this is this method. What is washer method? A washer, a lot of people, when they think about washer, they think about washing machine. But it's not washing machine. It's a tool. A tool washer looks like this. Right? Now to find the area of a washer is, how do I find the area of a washer? That could be a good SAT question. It's the big R. And this is R here. So that's going to be R squared minus R squared and multiply by pi. Would you agree? So in calculus, it's going to be integration from a to b of r squared of x minus the r squared of x, which is, this is the outer function and this is the inner function. Okay, outer and inner. The outer circle and inner circle. Yes. Yes. Don't forget pi. I just forget pi. Thank you. Are we all good? Or it could be integration from c to d pi r squared of y minus r squared of y dy. It could be like this as well, but c to d, because And we're gonna explain what's ry later. It's not r times y, it's ry. So I'm trying to say here is, what if today I have this shape? First of all, I don't know what the shape look like. Well, it's gonna be start with this. And we have a rotation, right? We have another function is a football, right? And we have another function, rotation. So now I want to have this shape rotation like this. And that's going to rotate. What kind of shape is this?
20 years.
Like a
2 apple slices.
cup of soup that's sharp.
Cup of what?
Like
It's
a
that
bowl.
bell line
Is it
from-
not just like deflated Pac-Man?
A bowl.
Deflated what?
Pac-Man.
It's an apple slice.
No, it's not deflated Pac-Man. This is three-dimensional. It's rotating around x-axis.
Probably the
Yeah, it's like a-
What?
We said it's like a bowl side-based sharp edges on it.
It's like a clam.
So it looks probably.
How the hell you get a clam? No, this is it. No, this is a three-dimensional shape.
Yeah, if you turn it the other way, you'd see the.
Makes sense.
It's like, you know the water cup, the triangle?
Yeah.
Yeah,
You
like
gotta- you
one
gotta
of
be
those-
good at visualization.
Like one of those, like the you know the like dispensable water cup.
I was thinking
It's like
the
one
same
of those inside of a.
Instead of like kind of basketball, yeah, inside of a tray or that kind of.
I mean,
Like a kind of egg.
not the, not quite. You know, would it make sense though? Because you wouldn't get bread.
But actually, I.
It's just gonna make I miss.
All right, Miranda, why are you on your phone? And Samuel, I don't know why you guys on your phone. What kind of shape are you gonna think of? Huh? No, it's three-dimensional shape. Pac-Man is one-dimensional.
Is that what you want to do?
This is the really special Pac-Man.
Wouldn't Pac-Man be two-dimensional?
I don't know. Do they have Pac-Man movie?
Yeah.
They do.
Yeah, it's called like pixels or something.
Are they three-dimensional?
Yeah. I never watched it. I've seen like the posters.
All right. So imagine that this is the watermelon, right? Imagine this is the watermelon that we have at full rotation. This is the watermelon. And if I take a comb, I carve a comb out of watermelon and I take it out completely. That's a shape that you are seeing. It's a shape of a thing carved out of comb. So in this case, what will be the volume of this shape is rotating around x-axis? I already kind of helped you before. Yeah. So it'll be integration from 0 to 4 pi the function of r of x, which is the distance from here to here, right? This r of x, which is we know is square root x squared. Don't forget the square. And the minus the comb.
Dude, I got that.
Does that make sense? So now I have a watermelon and I take out a cone because the cone has a different radius. You know, at 2, the radius of a cone is actually 1. Does that make sense? Now, here's the thing. I'm going to ask you to visualize a lot of shape. I feel like a lot of you guys are not very good at thinking three-dimensionally. You have to think it like you have a screwdriver and it's rotating that shape. You cannot just think like, okay, so it'll be easier is actually how much time I have?
Yeah, you got 20 minutes. 11 minutes. Have you seen the videos where they have like a thing on, they have like a sprocket on the end of the chain and then they swing around to the sheet? No, or like when you like.
So today, I could ask you to rotate square root x, and I'm gonna rotate the same shape, but I'm gonna rotate around y-axis. Then what kind of shape am I seeing if I rotate around y-axis? Like a flower?
A donut,
It's gonna be.
half a bowl of that. It's like.
But this does not have a circle.
Oh, you know.
It's like, again, it's definitely a flower.
Yeah, it's so weird.
Yes, yes, like a water.
It's a black hole, bro.
Have you go to Orlando Science that there is a place that you can just roll a ball and you go around, around.
Things where you like.
And to imitate how gravitational
Where it, is that like you know the thing where you toss a penny in and then it.
yeah, you can toss a penny. Usually it's marble. Is they will rotate if you just stick through it, and they will rotate, and it will when they go into the center, it rotate faster, and to show you like, you know, that's how like gravity actually works. It looks like that.
Oh, like a human.
Or some people can think of like this is kind of like a shape like a bun cake.
Or a flower.
Oh, yeah. It's like.
How is that a flower?
It's just a really special one.
If you can't imagine it already, then there's nothing I can say.
All right, so all right, so this rotation is gonna be around y-axis. Now you're gonna be like, oh wait, that's interesting. Now how do I calculate this value, right? So this is gonna rotate around y-axis. Are you able to do it? Okay, so a lot of you guys need to explore seeing different shapes. So how about this? If I have this shape, it's like this. But it's rotating x-axis. What shape am I gonna see? Oh, like a doorknob. I can see that. Or like a cement top, sideways. Or like a horn. A horn.
Oh.
Like a microphone, like horn, like. Okay. So this one's easier. So this one's a y equal to x squared. So I want you to find the shape that's rotating around x-axis.
It's like scaffolding.
What? What do you want about it?
So from 0 to 2. So how would I set up integral for this one? This one is gonna be what? Integration for what? Pi, don't forget pi. 0 to 2. X squared. Square. Dx. There you go, done. Is that easy? Okay, now this one's hard. So y equal to square x, but it's rotating around y-axis. I'm gonna help you this time. But you gotta pay attention. We are rotating around y perspective, so that means this is the slice that's rotating. Is that okay? Now I want to find out what happened from here to here. Now here's the thing. This is actually a washer. Do you see if I just rotate based on the red line? What kind? Do you see a washer if I just rotate the red line across y-axis? I'm gonna have a red line from here to here, right? And it's gonna form a disc, right? How many of you guys don't see the disc, the washer? Do you guys see a washer or no? Yes? Okay. So then you say, all right, well, we want to find out, this is a y perspective, so that's going to be in terms of dy. So that's going to be a function of y. So, but this is a function of x, so we had to convert it to y. So in this case, it will be x equal to y squared. Okay, so remember you got two different radius. The one radius from here to here. How far is that? Always 4, right? So it'll be integration pi, don't forget, from which value to which value? Which integration to which one? It's not 0 to 4. 0 to 2. Because stop at 0 to 2 because okay, so now we want a dy, that means function has to be in term y. What would be the big radius? The big radius here is 4, right? Does that make sense? And don't forget square. The y4 is because from here to here is always 4. It's never changed, right? What's inside? What's inside? Y square square. Because y square is here. The y square is from here to here. Because usually the function is going to represent, this is the y square, because the function is going to be represented by how the distance from the axis rotation to the curve, right? So that's going to be y square. So it'll be y square square. Is this okay or no? Okay. The last thing I want to talk about is this. Does this make sense or no? Everybody make sense or no? Yes? Okay, so if it makes sense, if it makes sense, is it possible I can, the hardest part is called off-axis rotation. The off-axis rotation means they don't have to rotate either X or Y axis. They can rotate off-axis, which just means like this. What if I rotating around X equal to 2? I mean, no, Y equal to 2, sorry. What kind of shape am I gonna see in this case?
Like sort of the x-axis.
Oh, -2, better.
It's like a carnival ride.
What are
You
you
just gotta know.
like
So like,
a bowl with a cylinder in the middle?
Huh?
A bowl with a cylinder in the middle?
That won't be a bowl because there'll be a hole on the bottom.
You get it.
What the bowl? When you have a hole on the bottom. No, the funnel's pretty useless in straight line. A funnel's supposed to gathering more to more condense. It's not a funnel. Yeah, you can say that, but that's a kind of weird shape, right? My challenge for you is, can you find a volume of the shape?
Go ahead, Kate. Give it a try.
Maybe it's like 2 halves of the compass.
Yeah, what happened?
It's not Friday.
I see you young like 50 times. I see you like young like 50 times.
Aren't they the same volume?
And even you did not hear a single word I said for the last 40 minutes maybe.
I think literally I came just for this part.
Yeah. I think everybody is tired. Those Science Olympia, those debates. Fabian, did you get some sleep?
Kind of. I was like in and out the entire day. How was Science Olympia? Good. We got, my team got second overall. We had 14 developers to the team.
Can I see the result?
Yeah. Okay, I can just show you.
I don't see this kid. What did he compete?
Oh, I don't have the.
Don't have the whole song.
I have the like.
Oh, so it's all.
I don't have like. Actually, I didn't mean to get. What's his name again? Yeah, why you rank me so low?
No, but this big one.
Really?
Before that.
I think I have to pay you on Thursday though. You know what I mean?
Why did it speak to me?
Your break
Oh
round.
my god, stop.
If you were there.
Why?
Back to the topic. And I would
Yeah.
say Pokemon
The
Go.
power packs, they got there.
While we were doing our speech,
What's the volume?
mind you, I said that I held my laptop for PlayStation
No
with me
volume.
and stuff for the whole game. Everyone started looking at my laptop.
Not like a shape of a
And you know,
And then I'm
Let it
waiting for
go.
You know what I mean?
they're so
Let's say, it's like shape of concrete. Would that not be the shape of the lamp?
shoot it with
No,
that.
that won't be a lamp.
well, it was big round.
Yes, it is.
And then one
But
side.
I mean,
if you
it-
build a lamp, would that not be the volume of the lamp?
I would have missed it.
I know, but
I'm looking at that would be
Okay, okay, so-
that's very
Shade, not a lamp.
Mr. Ye, how come you never use a 3D modeling to demonstrate the revolution?
What 3D model?
Yeah.
What do you mean?
Demonstrate the revolution.
3D model?
Yeah.
Oh, 3D printing?
No, 3D model to show the different types of shapes of the revolution on the axis, right?
Oh, I hate this.
What is a 3D model? This one?
Yeah.
On the Desmos?
You know, like, I told you. I'm gonna
All right, so shh. If the axis rotation's right here, right? If the axis rotation's right here, so that becomes kind of hard. So I will show you my trick. My trick is drawing a line from axis rotation. It has to be from axis rotation to the outer curve. You cannot be from the outer curve draw toward axis rotation. So this is what it looked like. Is that okay? So what is the function of this black line? That's the things that you should consider. And then there is an inner radius, which is here. Do you see that inner radius? That one's always 2, right? So that's easy. But what's the black line? No. What? Square root x plus 2. Excellent. Why? You break this line to 2. And this is 2, right? And this is square root x, right? So therefore, it's integration from 0 to 4, because that's in terms of x-axis, because that's a slice. And there's a pi. And it's going to be from 0 to 4, you're going to say, oh, okay, well, that's going to be big radius, which is 2 plus square root x square. Is that okay? Minus the 2 square and dx. And don't forget the square sign, don't forget the parenthesis, don't forget the pi, don't forget the boundary. Everything is important. If you're missing one thing, your answer is wrong.
Are we going to figure it upstairs?
Okay.
Anybody want water?
Yeah?
I would love one. I would love watermelon.
I have to go to bed.
I didn't put a drill on this one, so. But just eat it outside, don't drip inside my room. That doesn't look like you want a big spider.
It smells so good when it's okay. I might go.
Like it's so
Yeah. That's why I said.
Go to lunch.
She wanna go. Well, I lost my phone. I lost it and I had my. Oh no, I'm so good. So someone just has all my.
The area is the same now.
I don't mind.
Whoa, I think
And I lost it all.
Eat outside, don't trip outside.
big one?
Something is.
God, it's so sweet too.
Can you give me a
Sweet.
Bye, Mr. A. Thank you, Mr. A. Oh, it smells good.
Thank you. I'm asking later if everybody comes in here. I might come back if all my friends come in here. And then maybe we can go over the website.
He didn't. He didn't want to drive.
Nah, it's just like, yeah, like nobody on his team, bro.
No, he was on 18.
I was on anything.
Like, he was on 18.
Where
Yeah,
would-
should be okay.
If I didn't have family over for UFC, I would've gone.
UFC.
Yeah.
UFC fight party.
Yeah, I had like family over all day.
You lose money or lose money?
Oh, I won so much money. Oh my gosh. I think I put like 300 down and I got like 500 to 700 back.
Do you always win?
Yeah, I was win. It's like one of the, like sometimes I'll lose because sometimes somebody will get like knocked out like out of the random, but like fighting is like one of those sports like you kind of know what's gonna happen. It's not like football or anything. Yeah. But it's like even like football, like that's like a coin toss.
Because there's so many different pieces in like.
And there's a
each
lot
sport.
of, there's also like referee
Yeah,
can
referees
change
too.
the game too.
Yeah.
For football and basketball, long as like a free throw, boom, you're done, right? It's like not even a player. It's like, dude, you didn't get fouled. Like, we don't see LeBron goes like, like
Well, so not stuff you can get like penalized in.
I mean, yeah, like this weekend, bro, someone got cracked in the jewels like 4 times, bro. It was so stupid. It was like the Asian guy like didn't understand English and they didn't have a translator, so like he like kicked them down there once, got a warning, didn't understand what happened, got kneed the other guy down there again, and then kneed him down there a
Well,
third
don't
time.
they know that you can't do that? Like,
I mean, yeah, but like he got like 2 points taken away, which is like rare for like that to happen. He got 2 points taken away and he didn't understand what was happening because they didn't have a translator.
Chinese guy is fighting.
Yeah. I think his name was like Zhao Wang or something like that. You heard.
oh, now you want my help?
I don't want to like.
I offered it like 2 minutes ago.
Yeah, no.
I'm in the middle of something now. I gotta study for Elkin's test tomorrow.
That's tomorrow. That's a tomorrow problem, not today. Not right
I
now.
don't pay enough attention in class.
He's watching basketball.
Watching back. You know who does that? Like every single. I thought you were joking, bro. I go back there in physics, basketball, hold up. I mean, I'm not gonna lie, that's disrespectful because Greenwald, but like,
Bro, you're watching UFC and Greenwald, like,
okay.
actually, it's like 50-50. Either you're working on calc or you're watching UFC.
Yeah, I'm not gonna lie, Mr. I be doing so much beasting, Mr. Greenwald.
So yeah, you can put 2 graphs there, and I'll show you how to do it.
Yeah, we can put Big Dog up. Yeah, we're not doing anything today.
Yeah.
There's like 2 questions on there, right? I didn't do it. I like soft.
Hi, Mr. Ed.
Hello, Mr. Also, our testing.
Watch your video?
I did watch the video, but you didn't post. You didn't post 6 periods. So I didn't get to hear anything you said at all.
I'm not
You
gonna lie.
said that he was happy you weren't here because you're really loud and annoying.
Yeah, I'm not gonna lie. There was like 0 talking, and we were just like, no problem.
Yeah, we yelled at
Up to the
Brandon.
4th period.
Over
Fourth
in
period was
the-
yapping apparently.
Oh yeah, I was pissed.
I know.
This kid washer.
Yeah, we were locked in. We didn't like no
No,
work.
Shakespeare is so much nicer. It's out of the annoying junior kid.
Yeah, I don't like the annoying juniors here.
Yeah, you want to move the table finally?
Jalen put
Yeah,
that
also graph.
Over here. Yeah, you want watermelon? Watermelon?
watermelon.
Yeah.
Good, bro.
You should have paid DK so you didn't watch it.
Aren't you an AD, bro?
Okay, but I learned that. I learned that all the way. I learned that all the way in like November.
No, you did, you did.
Guys, get your prom
But you're
tickets.
saying like you're not new, right? Like,
I don't say those kids, bro. Those kids get like zeros like this.
don't you get it on the video?
Lowest year grade I ever got on a test was 27. Everything else was
I think my lowest grade in EA was like a 37. It was on optimization.
Mine was on related rate. Optimization in AB, I got 100. In BC, I got watermelon. Spin. Model.
I think you're right. You're gonna learn to be
Spin,
seated.
spin. No,
We're not learning anything.
We're not learning anything. Model.
Okay, do you realize what the plan was before everybody came in here, Greg?
Morning.
Cheese.
No.
All people that allow. Yeah, I'm not gonna lie, not right. People back
Oh my gosh.
I'm getting your way. I'll sit there. I got it.
I gotta go.
What? Yeah. I could have kept doing my notes during the lecture. I got it. Did you do the ABM? When I answered, hey, total answer like seven. Okay.
Seven?
Yeah. And then I sitting down. Oh my god. By the way, you do the thoughts, right? And then you get to the like, okay, like. Is that it's like you went, honestly, how you doing? Yeah, you did. I'm here, I can show you my homework. I'm here to show you my homework. I didn't even see all. I didn't get first question. Look, I didn't be on that one too. And then we're just not right. And then I did a lot of I'll type out another. Watch this was a lot easier. Oh, we played Hangman? Because we haven't done all access. I didn't see any. Oh, you didn't see any? Yeah. I'm not gonna lie, I think it's too late to do everything. Oh, yeah.
Right there.
Oh, sweetie. It was like that, but it required so funny.
Hey.
That's more. You know what you gotta do? Hey, our mom. What do you think? He was probably like 7. He wasn't like. Yo, oh, they're playing Hangman.
It's like bombed out.
Wow.
She would never.
You're gonna want to watch it.
You made that.
Watch. He like watch that. Point start like. What?
And I hit you better.
Yes, I got send
Microwave before you kill yourself.
Where do I put it?
I will be able to help.
You guys win. Oh, that's fine. I don't know if it's okay, but Homer.
But also look at it based on the price.
Yeah. I'm not.
Shut up.
You get
Yeah.
I might need to try it.
I was like good old so bad. And then like I quit.
Just bone.
I know football. I think I did.
Oh my god, it's huge. You know,
What? What?
Ben Goodman, he placed again.
I know he's taking pre-cal AP exam without taking pre-cal.
Generally higher.
I told him to take it. He probably did better than half those breaks.
You like teaching him like a couple things?
Yeah, I teach him.
Okay, those kind of in there.
But he already know more than think on certain things than me.
Do you think he's just gonna go straight to calculus next year?
No, he's going to straight to calculus regardless. He will pass it. Fine. Oh, that's great. I remember looking at
He's your next brother.
I don't know. He has a very. He works hard too. But he has actually like he just like very. He's like he can use whatever he learned from the past. And he can actively make sense. Like for example, you get circles, right?
Hey.
This one is literally 2.5. Yeah, it's like you know that 25 points.
died.
5 minutes later. And that's after 2 minutes. It's not even after like. 20 minutes left.
You here?
They're watching it. They don't remember you.
My brother were in the same grade, and his older brother was like a mean kid, and my brother was like never touched it.
Shout out.
And then
Oh, let's just watch the top.
I have videos at my house, like his older brother, my brother, and me like playing pool together. It's like my brother and me friends.
Up and over.
And then it just so happened that like, I guess I was child.
Yeah, I was like, do you remember this story?
Like my mom would tell you, but
So
he's
it-
in front of me in orchestra. He's a viola.
You would say hi good?
Like today, I was like, That's in sixth place.
He's a shy boy.
Yeah, and I'm not good at talking about I don't know.
I'm talking about it. Not good at small talk.
Small talk, but like literally just like absolute randos, I can't do.
Honestly, I can talk with him. I'm like, do you understand this stuff? He doesn't say. He doesn't show like it's like static person.
Yeah, you bet.
Person.
It's not.
Oh,
That's last year. Remington.
Oh, yeah,
Remington.
I don't know.
Last
Oh,
year.
wait. No, I don't think
Elsa.
Okay.
Elsa is also brewing. It's like brewing all.
Eastern.
She's like so. She's never like show any like up or down, like frustrated. Or,
I need to do more.
how?
I need to be
Have you seen her like that? I've never seen her. I've seen her in exciting. Like she's still like. She's already like.
Neurotic. That's what we're in. You like emotional instability. So if you're high neurotic, your emotions are active. If you're low neurotic, you're very calm.
I've done.
And we did a personality test you can take online that tells you like your neurotic score.
I know.
Mine
Yeah.
was
It's
but I've been like there, you know, really low, you know.
Hey.
So how was in the competition? How was in the competition? No, the reason why I love it, I was like, yeah. You don't think they're gonna get information.
I'm going for
Who was supposed to teach you that?
She dropped out. Riley was like,
I'm
yeah,
still
I
low.
was there.
forgetting every single note.
It was like a yeah.
What? Negative 10. We're like,
No, I think that's what she wants. But individual. T. Could have finished some three. I got one more question, bro. One more question, bro. And you factor x squared minus x minus 2 wrong.
oh, he can't back to.
It is the last question. The bonus question. You can't get a factor, right? You got a factor.
you got it.
He's like, Harris, you know?
No, I would have done what it's
Thank you, dude.
I think if I take it 2-1.
You should get
What is that?
What?
No, I want to get this shit done with for the week.
What? Oh!
He's taking like Spanish
How can we try GP?
Ah!
No, I'm not even on Spanish to like regular. And you speak Spanish.
He's always behind.
You'll be the only Hispanic. No, I'm not failing it. Listen, it's just like the woman asked for very specific stuff. So like, when are you going to like 60s? But she's like, oh, that's not what I asked for. If I give you more, I should be getting 110. Not 40. But it's okay. I have to get it done. It's for bright features. I took French freshman year, but I need 2 years of a consecutive language. And I didn't want to take French too because I didn't pay attention to French one. I just used Spanish. What is it? I'll take like AP Chinese. If he takes an AP class and passes the exam, I think that just counts as 2 exams. I'm not sure. I would fail that before. He doesn't talk. He doesn't speak to me. Oh my God! No, because you gotta force it. Only speak to him in Chinese. You don't understand. Oh!
That was a good move. That was a good move. Because myself, yeah.
See?
Someone excuse your own name because it's all caps. I'm too lazy to change it.
We played more. We played less.
He's winning his words.
Pick up paper.
Yeah.
It is.
Do you want to play? Is there one? One. Okay. Have you guys missed the question description of it? Yeah. Are you gonna buy a box? Ashton sits around with my pop. Think about like 12. Oh wait, well. Class.
That looks
Think about it, guys.
Ah.
I think it's Nelly.
Alright, give me a pool of magic.
Oh my gosh. I think that's good.
Look at it.
Stop. You know how much I'm sure.
Oh, floating pin.
Did you?
Carrie.
Oh, not that one. I put it on the ball.
Oh my God.
No.
Oh my god.
Go.
Floating.
Go.
I love it. That was throw.
Okay.
It's there that hits the line. I can literally curve off the table and back.
Wait. Okay.
No, you said no, I did it. Because you're floating it. He knows
Salt and powder? Like,
The scope was like.
but like bottom was so
Whereas we're not 50 cents basic.
Oh no. Like, why did I know? It's like very
He had the
Another 50 cents.
No, it's like
Oh, never.
I feel like
It's $4.
no, no. 70. Guess what? You're so overreacting because you're not walking anywhere. Guys, I'm starting using my brother's electricity.
Doesn't have
Huh?
Not eight.
Honda Polo.
Yeah.
UPS, so the long drives are his old car was taking too much gas. My parents switched him to electric.
like a solar.
Yeah. Really?
I'm guessing.
I start off with that's obvious. Okay, I think it's Fiona.
Which?
Ah!
Wait, I'm trying to.
Barely.
I know the round.
Doesn't matter. No.
You're gonna have to make a neck to the wall, okay?
Hey, you guys gotta put it back.
You gotta think about it.
I'm like,
Yep. Yeah. I speak
You
it.
saying that like you.
No. Think about what I, no,
Ellie, go. Ellie.
holy man.
you ready? Pearl. Water?
Yeah. Yeah, I said it was right. Swap.
Oral, swipe or no swiping?
Yeah.
Whatever it is.
I was gonna say no. I was like, what the?
Good one.
Yeah. Think about this. No, that makes you.
Wait, why you were killing yourself, Fiona?
Because I said water. Everybody looked at her like,
Yeah. See what I'm like?
you got it.
No, yeah, but I take my son to ping pong practice, and I want to play so bad. I don't listen.
I feel good right now. It's like looking again. My issue with my forehead is like I keep going like
Something like that. Don't lift your elbow.
it's like when I think about it, I remember just feeling that, but when I'm not thinking about it, that's why my forehead.
Wait.
It's because you're watching your forehead.
That was funny.
I'm intimidated.
In my opinion.
She likes it, but I don't think I've tried it.
You're talking about walking
Quinoa is one of her unique weapons.
It's not like.
Actually, that's pretty cool.
It's just about
Yeah.
Not white, but it's like all white.
How did you guys feel about something?
Our team called us to the, we got third overall.
Wait, you guys beat Honolulu?
We beat Labras. We beat Labras by a lot. We beat them by like 20 something
Yeah, they
points.
suck too.
Or something. You guys got beat by Honolulu.
Oh, that's so tough. It just started spinning back.
Each team has what, like 14? 15? 17 years, and then the rest of you were.
Bill.
I'll give you the next.
Oh!
Only you and then.
That's just Thompson.
And I'm not gonna lie, I have no idea like what other word to describe this as. I'm just gonna say
You're
heat.
coping. I'm peaking. You're coping.
What? Was it you? Who's
Yeah, but you do have to remember my. No, just not that.
But I think 4 of our teams, like I've ever seen and 4 of our teams got 5 mistakes.
I like it.
On April 11th.
Yeah, but like, you know, I was just me like rich, but I kind of like stay like.
It's
Let's get a really good number. Let's get like 20. So, 1, 3, 5, 7. You're sitting all over the place. I count. Okay, the first time. 1, 2, 3, 4,
Wait, Daddy, what?
You guys can be big.
1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. No! That was like the easiest way.
Okay. Helmet.
1, 3,
okay.
in the middle.
Really said her word. I'm gonna get her right.
The second you backhand like outside of your nose. I'm just waiting.
Oh wait, I don't know.
You should get it.
Jamaica. I'm gonna say dragon.
No, no.
Hey.
She took it.
You don't know?
I literally just took a look into
Oh my
my
god.
I feel like already get
Oh, your birthday.
Finish
Yeah.
it. Finish it. Baby me.
Anything about this.
Oh.
Oh.
That you already had all.
This has to be like really. This one has to be like really good.
He.
Oh, yeah, I did it again.
He?
It is.
Oh, yeah.
No, it's because your brain is like late. It's worse than like calculating. He said he was being irritated.
Oh my god. But you
I did. Before ending.
You'll be able to take the Jamaican bobsled team.
they're really good.
And they're they're like
Yeah.
they are the Jamaican winter Olympics.
Oh my god.
Like that's not gonna be a thing. Okay.
What?
Dark gray.
Ah.
Dark gray.
There's a ball with thunder.
I want to go like Megan.
That's what I mean. Like I go like this.
Yeah.
So bad.
And what?
The practice house. Send it. Like any.
You know what that is?
One.
I don't know.
Three. Five.
That's the plan.
I can't count like odd numbers. No, we can count.
Okay.
Rain.
Rain?
Hey.
Scary.
You want this?
R.
No!
We have a question. Okay, guys, speed round.
I think I'm S.
Okay.
Third thing.
Speed round. This should be easy, like.
Oh boy.
Yeah.
Charade.
What?
So we're playing charade.
And I was saying Everybody's like black their hand. Be vague but quick, okay? Because I know there's one way to participate and then everybody.
Oh.
Video game.
Saw that.
Whoa.
Green.
Minor.
I know this.
You would know.
Race.
That's not one. I just called you on.
That's it. That's mine. Really? What was the first question? What was the first question?
When you said word, what did you say? Well, I thought you know, so you know video game.
Yeah.
Yeah, that's what I thought it was when I was little too.
That's so old. That's just like wow.
I think 4 minutes.
I just like wanted to go to a meeting. Like, okay. You're gonna get it back on track.
Hey guys, hey, that's what makes it fun. For the imposter, hey, I will be out of the wall. That was our turn. Okay. Oh, that's a good one. But okay. Wedding. Okay.
Dragon.
It's Nelly.
Come on.
You know, like, wedlock is wedding, like wed in the middle.
Yeah. No, but. No.
Oh no.
Sorry.
I don't think it's useful now.
No pin avoided. I want to
Wait, fine. Wait, I know you know.
Okay.
I'm gonna say it's like about.
Oh. Blu-ray.
You are my special.
Okay, here's my
Right.
No,
You guys don't think it's useful?
Right.
I word is pretty useful to use.
Yeah, bro, you guys never have those swim bait people because they have swim bait, like they had the CD at the end of them. You know the song is like the little duck that was singing and whatnot?
No,
but
it's something like that. I think it's originally.
Yeah, stop it. Down here, we're kind of just taught to swim by being brought into
Yeah, my friend's gonna be.
Oh yeah.
Yeah, I got
But it's not. It's not. It's not. It's work at all for us. It's not chainsaw man. But then they were like, they're one of the characters. One that's.
Yes, you like Dewey the duck that's the swim. And like there was a CD behind it and everything. Like, we would get in school, you know, our people do it in the house.
Yeah, what are we doing? What is this?
Oh, did you know? Isn't it for time?
Dude, I saw the 3-minute video of you putting a chopstick in a drill this morning.
I know, I saw people recording.
Yeah, I heard about that. What is that?
Can we do that?
Have you noticed? It was a random piece. A random piece.
I ate all of the watermelon.
They've been drilling watermelons.
What?
The study away.
And she they didn't like, I guess they forgot. They're like, this car is not right. No, it's not even and they just like, well, go long ago. You get what I'm saying? I don't have it.
Okay, your notes out.
They think, and if we do, Mark.
Honestly, I think I met his mom is 25.
What? What?
Why? Gonna go bad.
Because I was getting over
Leo Jones.
I have $5 cents to take it home on. No, why do you take
Let me indulge this.
Not yet. Later.
What are the outfit that's already on the screen? Dude, I'm looking at that piece of watermelon just like that dog.
Now she does.
All right, so shh. Get your notes out. We're gonna start stuff.
I ran up.
To get rid of the lights, you don't have to go.
Where were you?
Yeah, you should shake your head both ways. And your eyebrows.
Wait, how do you Okay, shave your that's kind of you have to look when you long hair.
Do you still have this paper?
Yeah, I need
I need one like.
Come grab one.
I mean, I don't know. I know.
Go to the Amish market. They have like the best food.
Oh, what have you tried?
Yeah, they have like good food.
I feel over.
Because they know how to.
All right. So today we're going to talk about, we already talked about polar coordinate, and now we'll review about that. So, so we're going to go with, do you guys know where is, let's just say if I give you 5 and a 3 pi over 4, do you know where is that? 5, 3 pi over 4. 5, 3 pi over 4.